So now we're going to look at division of polynomials. In the past, we've looked at adding, subtracting, and multiplying polynomials and factoring them. We've also now looked at adding, subtracting, multiplying, and dividing rational expressions, which included polynomials. So we've had quite a bit of work with polynomials now. But now we're going to look at dividing. It's the one thing we kind of skipped over, and we're going to come back to it. It's really combining all of our polynomial work with the rational expression work that we've done already to this point. So dividing polynomials, one thing that I want to point out is that in division and the distributive property are kind of related. So let me show you real quick what I mean by that. That'll kind of initiate this conversation. So remember the distributive property. I'm sure all of you will recall something like 3 times x minus 5. And of course, you multiply by distributing the 3 in, you get 3x minus, well, 15, 3 times 5. Well, you can also do this with fractions. We've seen this many times now too. We saw it especially in that when we did the slope-intercept form of a line and we were looking at slopes and distributing those through. But we've done this quite a bit now. So you could have something like 1/3 on the outside times maybe x plus 7. Okay. And so here, when you distribute the 1/3, you end up having 1/3 x plus 1/3 of 7. And when you really combine those, what do we have? What, x over 3 and 7 over 3, essentially? And that'd be a way to write those each as a single fraction. But remember also that when we have common denominators, you can combine the denominators and put it all over the same, all the numerators over the same denominator. And so here we could also write it as x plus 7 all over 3. So the combining fractions with a common denominator, if we were to undo that, you're kind of distributing, in a sense, that 3 to the two terms on top. Okay, so it's kind of splitting up that sum. Okay, so the distributive property multiplying a fraction of 1/3 is really no different than dividing both terms by 3. And so the distributive property can be used to split up a fraction when it has a single term in the denominator. Okay, so that's a principle we're going to need to recognize. So as a general rule then, if you have some expression that follows the format of something like a plus b all over c, you can separate it into two fractions with the same denominator, a over c plus b over c. Okay, so it's like pulling apart two fractions with a common denominator rather than putting them together. All right, so that's kind of the basis for some of the more simple dividing of polynomials, particularly when we're dividing by a monomial. Okay, when we divide by binomials and trinomials, the process is a little more complicated. I'll talk about that in a future video or in the next video. But for right now, we'll focus on monomials on the bottom. Okay. So, all that being said, let's look at an example like 24 x to the 5th plus 18x to the 4th minus 42x to the 3rd all over 6x. Okay, so here I have 3 terms on top, 1 on the bottom. I'm dividing a trinomial by a monomial. But like I just said, it's no different than just distributing this monomial to each of the terms on top, essentially separating 3 fractions with a common denominator. Okay, and so that's the first step in simplifying or dividing this. So I'm going to take that 6x and divide it to the first term and the second term and the third term. Okay, so now I have created three fractions, each with a like denominator, common denominator. And now I can use that to simplify each of the three fractions separately. Okay, so it's kind of undoing the whole finding an LCD process. We're kind of reducing them back down to things that aren't the same. So 24 over 6 is 4. X to the 5th over x is x to the 4th. So I get 4x to the 4th. And this fully reduced, I don't have a denominator now. Or my denominator is 1 technically. Add to that, well, 18 over 6 is 3. X to the 4th over x is x to the 3rd. And then subtract, and 42 over 6 is 7. And x to the 3rd over x is x to the 2nd. Okay, and so I'm left with just a polynomial, 4x to the 4th plus 3x cubed minus 7x squared. It's a trinomial, and it would be the final answer to this original division. Okay, let's look at another example. These do get a little bit more complicated. Obviously, at the beginning here, there's a lot going on. There's some, decent sized numbers there with lots of factors and variables with larger powers, and what we see more regularly, but these all do simplify pretty well. Let's look at something like 56 x to the 8th minus 42 x to the 5th plus 70 x to the 6th, all divided by 28x to the 7th. Okay, so again, we've got larger numbers to deal with than what maybe we're used to or familiar with, but it's okay. And again, this monomial on the bottom is going to split up to all three terms on top. And now both of my examples had trinomial over monomial, but it doesn't matter how many terms are on top. If you have a monomial on the bottom, it just distributes to all of those terms. So let's go ahead and do that, and then we'll simplify. So starting off with 56x to the 8th over 28x to the 7th. We got minus 42x to the 5th over 28x to the 7th plus 70x to the 6th over 28x to the 7th. Now I'm going to try to reduce these. Well, 28 goes into 56 evenly. The answer is 2. X to the 8th over x to the 7th is simply x. So that first term reduces all the way down to just a 2x. Keep my minus sign. Now 42 and 28, 28 does not go evenly into 42, so I'm going to be left with a fraction here. I could reduce them though. They both are divisible by 7. I see that, and I also see a 2 in there. So let me reduce them both by a 7 real quick. Divide 42 by 7, I get a 6. Divide 28 by 7, I get a 4. They're still both divisible by 2, and so we'll take out a 2 there. I get 3 and a 2. So this will be a 3 on top, a 2 on the bottom. And when I simplify the x's, notice the bigger power is on the bottom. So I'm going to still have an x squared on the bottom here when I subtract the 5 minus 7. So this ends up with a 3 on top and a 2x squared on the bottom. Kind of keep all that organized, right? So 3 and a 2, 3 on top, 2 on the bottom, and then you get the x squared on the bottom from reducing the x's. Then here, 28 again does not go evenly into 70, but I know that they both have a factor of 7. So I'm going to divide out the 7. That'll be a 10. That'll be a 4. And they also both have a factor of 2. So I could divide out a 2, that makes a 5, and a 2 there makes a 2. Also, the x's, when I reduce 6 minus 7, I get a negative 1 or a 1 on the bottom. So I get a 5 on top, and I get a 2 and an x to the 1 on the bottom. okay? So my final division here, or my final answer from the division, is 2x minus 3 over 2x squared plus 5 over 2x. Now if you were to have this, well, yeah, I wouldn't even say that. This is a nice simplified form from the original, obviously, but it is 3 separate fractions, and sometimes it's nice to have it all in one fraction. Although if I was to try to combine these, get an LCD and combine them into one fraction, I wouldn't turn it into this top one because my numerator I would use is just 2x squared rather than 28x to the 7, so it would be a much simpler fraction.